Hello. So in this video, we are going to solve some problems. Okay. I will not solve all the problems, but I will solve some of it. Okay. So first, I'm discussing this 15 number question. Okay, this one, and as you can see on your board, that this V is this thing r cross till n number of time, and we want to see if this is a vector space. In fact, it says it is a vector space over R. Okay. Showed you the example R2, I think, or R3 over R. So this is just Rn. That's fine. Is be a vector space over the field of complex number with the operation of component wise adding, addition, and multiplication. So the answer will be no. Why? Because let's see. So coordinate wise multiplication means this one, right? This is our multiplication. C A1 C A2 till C A N. Okay, so this is the dot product, but you see this one is V. V is our what? You can denote R cross R, something like this. You can denote it by R N. And what is this over which field? V is equal to C, complex number. Okay, and dot is from F. Oh, sorry. Why did I write V? This is F. A dot is from F cross V to V, right? So, if you take C from complex number and V is Rn, C dot V should belongs to this V, which means Rn. But as you can see, if C dot any V, this one, let this is a vector. Okay, so C is complex number and this one is all real numbers. You will get C into A1, C into A2, C into, and it may not be always a real number. All of these entries should be real number, but we may not get real number. So this dot doesn't take like these two things into this V. Okay, this Rn. So this is not a vector space. A particular example can be, you can take complex number this as I, and you can take let's say 1 2 3 or let's say just 1 1 1 will be fine, right? Dot, so this will be I, and this does not belongs to Rn. So this one, that answers the question, that this one and this one is not a vector space. Okay, with this definition of addition and dot product. Okay. Okay, so now we will discuss the 16th one. Okay, so let V be the set of M cross N matrix with real entries, and V is a vector space over R. That's fine. Let F be the field of rational number. Is V a vector space over F with the usual definition of matrix addition and scalar multiplication? Then the answer is yes. Why? Because let's see. Let's just an example. This one, let's say we are talking about a 3 cross 3 matrix. Okay, Uh, what is this? Well, okay, with real entries and okay. Okay, so you can see the addition will be like this, and this will not be a problem because real and real plus real will be always real, so that is going to be fine. But also, not I shouldn't say, but this one is also going to make sense. This thing, like if you take C from rational number, let's denote it by Q C, and dot this A1, A12, A13, and so on. This you can fill this out. This one will be CA11, CA12, CA13, CA12, C sorry 21, 22, and you can do it. So the problem in the last one was that we multiplied complex number with a real number, and we saw that the answer is that it may actually go to complex number, and that's what was creating problem. But here won't have that problem because rational number this rational number into this real number is again a real number. Why? Because rational number are a subset of real number, and a real number will give us again a real number. So this matrix ends up again in MNR. In this case, M3R. Okay. So the dot will make sense. This dot definition will make sense, and the rest of the axiom 1, 2, 3, 4, 8, that will keep holding true. You can check that. You don't need to check that because it holds over R, so it will hold over Q as well because this is a subset of R. Okay, so this solves the problem 16. Okay, so this is a vector space, and let's pause for a while, and we will then see 17 or 18 maybe. Okay, so we will do this I think 19 in this time. Okay, so let's do this 19 Okay, what is the question? This one. Okay, so we have this property, right? C 1 plus C2 x is equal to C1x plus C2x. Okay, for all C1, C2 belongs to F and X belongs to V. Okay. Uh, can you remember which axiom this one was? Let's go to the maybe starting of this and we can see. Okay, where is that one? Okay, this one. This instead of A, B, I have wrote C1 and C2, and this dot X is equal to this A dot X, B dot X. Okay, so that one need to be satisfied for a vector space. Okay, so this thing I forgot to add the dot here. Okay, so what will we do? Let's take this 2 plus 3 dot x is from V, right? And V is of the form, if you see this one, V is of the form A1 dot A2 from R. Okay, let's see. How about 5 cross 6? What is this one? This one is equal to 5. This one I am calculating. C1 is equal to 2 and C2 is equal to 3 I have taken, and X is equal to 5 comma 6. So what will you get? This you will get 5 dot 5 comma 6. And what is the definition here? This one is the definition. Can you see? Multiply with 5 on this one will be 25 and this one will be 6 by 5. Okay. And can you calculate that this one? This one is 5. Sorry, not 5. What I am doing. 2 dot x is 5 comma 6 plus 3 dot 5 comma 6, this one. So this will be 5 into 2, 10, 6 by 2, 3. And this one is 3 comma 3 dot 5 will be 15, and this one will be 2. So this one gives me 25, 3 plus 2, 5. Okay, so can you see these two are not equal? Not equal. So this condition is not fulfilled, this condition. So this means not a vector space. Okay. Now let's pause for a while. Which exercise should we do next? Okay, this one was you can do 20, 21. Okay, I don't think they are pretty difficult. Okay, how can you do 22? 22 is this one. Let's copy this one. Okay. Okay. First, can you recall the definition of M cross N? This is M rows. So M rows and N columns. Okay. This matrix. Okay. So how many elements will be there? Let's say A11, A12. This will be A1N up dot dot dot. This will be A21, A22, so on A2N. And this will be AM1, AM2, and so on AMN. So there will be total MN entries. Okay. And Z2 is this one, right? I have already defined this one in one of the lectures. I think where I defined field. Okay, Z2 is this field. 0, 1. Okay. And how are we adding here? 0 plus 0 is equal to 0. 1 plus 0 is equal to 0. 1 plus 0 is equal to, sorry, 1. And 0 plus 1 is equal to 1. And 1 plus 1 is equal to 0. And so so for each entry we have two options, right? It can be 0 bar or 1 bar. What is the definition of matrix? Bracket this M cross N, bracket this entries should be from F, right? So these entries, they have F, and these are from Z2, and Z2 has two elements. So each time we have two options. So 2 into 2 into 2, and this will be 2 to the power mn time. Okay, so this must be the answer. Thank you.